Okay, let's do one more example. It said that incorporating costs into the simulation analysis. We can incorporate the costs along with this scheduling as well. So this is an extension of the previous example, and we are using a different set of data for this example. Okay, so as you can see that the information given is for the activities, their predecessors, their durations, optimistic, most likely, and pessimistic, and their cost rates per day in case of optimistic, normal, and the pessimistic situations. Okay, then the first step is actually, so what we want to do is now we want to simulate the duration and want to simulate the costs. So for this, first of all, we need to draw the network. So let me show it to you over here, and I want to draw freehand over here. So the data for the activities which we have is like this. Okay, activities data. So I have the activities A, B, C, D, E, F, G, and H, and their immediately preceding activities are nothing. For B, C, and D, the activities are A, and then for C, D, and E, the activities are B, 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 and F, G, and H. C, D, F is C, D, and D, and E, and G. Yeah, so I have just copied this data over here. Now I will try to draw the network. Okay, so I will start from activity A. Activity A has no preceding activity, so activity A. So I will draw the node for activity A, then B, activity B, okay, and then C, D, and E all have B. So I will put C over here, D here, and E here. So like this, C, D, and E, and then F is C and D. F is here. F should be here, from C to F, from D to F, right? And G is D. G is here. G is here from D to G. And H is E and G. H here, E and G. H here. H should be here. E to H, E to H here, and G to H, G to H here. And F has no immediately following activity, so I will put a finish milestone over here. So F and then G. So now I have this network. Okay, I don't need to do the forward pass and backward pass calculations. I just have to identify the paths in this. So there are actually some paths over here. So one of the paths is ABCF, ABCF, ABCF. The other path is ABDF, ABDF, A, B, D, and F. Another path is ABDGH, A, B, D, G, H. And another path is ABEH, ABEH, ABEH. Yeah, so this is the backbone of this, for the solution of this problem. Okay, well, there are only 4 paths, that's I know. Okay. Okay, the next step is to do the work in Excel. Okay, so here is this Excel. Let's make it a little bit bigger. So as activity, activities or activity, whatever. Okay, and then A B C D, A B C D E F G and H. Yeah. Okay, and now I don't need to put the immediately preceding activity that we have already taken care of. So optimistic time, most likely time, pessimistic time, and here I will just input the data. Okay, and then this is for firstly for the cost and for the durations. So this data will be for the duration, and then the next data will be for the cost per day. Okay, so same, optimistic, most likely, and pessimistic. Okay, so now I have added the data for the activity duration and activity costs as well. The next step is to, let me readjust this to values. Here I will add a column for the simulated duration. Okay, and here I will add the data for simulated unit cost or cost per day. Okay, cost per day, simulated cost per day, and then that will be the activity cost, simulated activity cost. Okay, here activity cost. This is the simulated activity cost. So here, as we did in the previous example, so using the crystal ball, I will define assumption using the beta distribution. So I will define the beta distribution. Okay, so beta part distribution, click OK, and then select the optimistic value, minimum, likeliest, and the maximum. So it will be 8, 10, and 16. And similarly I will add all the other values. Similarly for the cost per day, I will also be using the beta part distribution. So here I have entered the assumptions using the beta distribution, beta part distribution. Next is I need to enter the formula for the simulated activity cost. So simulated activity cost will be the simulated duration multiplied by the simulated cost per day. Okay, so enter this formula and then copy it for all the total for all the activities, and here you can have the total project cost. Okay, total project cost, so which is the sum of all these values for the activity costs. So here it will be there will be the total project cost. Okay, so in this case, if we just have to add the find the total project cost, so we can put it as the define assumption. But if you want to also find the duration of the project, so we can also add it as another forecast value. So let's add the duration value. So for this I will have these paths. Okay, so let me put the paths over here. So what are the paths which I determined before? These paths were this one, ABCF, ABDF, etc. So the paths are ABCF, ABDF, ABDGH, and ABEH. And the duration for these paths is, so for example, for ABCF, so the simulated duration for A plus the simulated duration for B plus the simulated duration for C and plus the simulated duration for F. Okay, and similarly I can enter the formula for other paths as well. So here now I have added the formulas for the paths and the total project duration. Okay, project duration will be the maximum of these values, maximum of these four values of different paths. Okay, so I have now two forecast cells in crystal ball. One is this define forecast project duration, and I have another forecast value define the total project cost. So I will click define forecast, and for its name I will point towards this cell. Okay, so this will be the total project cost. So now I am ready to run the simulation. So as before, I will perform 10,000 simulations. I'm clicking the start button, and here you will see this time I will have two values. So one is for the project duration, the other will be for the project cost. So let's put these values here. Okay, so the simulation has been completed, and then now I have these two charts. Yeah, so one of the chart is for the project duration, the other chart is for the project cost, and next we will analyze these two charts.